If the GCSE asks you describe the arrangement of particles in a gas for 3 marks and you answer the particles are spread out and move freely, you might score a 0, though it sounds right, but GCSE expects exact key terms. Let's start thinking like an examiner. I'm Miss Neha and today we'll talk about kinetic particle model of matter. Quick question. Ice, water and steam. They're all the same, which is water, but why do they behave differently? Let's find out. So particle model explains this fact precisely with 4 key ideas. The first one, particles. Now everything, every solid, every liquid, every gas, whatever you see around you, every matter is made of these tiny particles. These particles can be atoms for an element, like gold element is made of gold atoms, or ions, any ionic compound like salt is made of sodium and chloride ions, or any molecules like water is made of water molecules. So particles can be atoms, ions or molecules depending upon what substance we are talking about. The next fact is that these particles are always moving. They never stop. In solids, the particles vibrate in their place. In liquids, the particles slide past each other, and in gases, the particles randomly move in all the directions. Whatever the state be, the particles are always moving. The third idea talks about the spaces between them. Now solids, they have the least space between them as the particles are closely packed, while liquids have some spaces and gases, they have the maximum space between them. The fourth feature talks about the forces between them. The strong forces of attraction are the reasons for the minimum spaces between the solid particles. Alternatively, for gases, the forces are negligible. Remember, if you say gases do not have any forces between the particles, this is wrong. Correct way of saying it is gases have negligible forces of attraction between their particles. The word negligible is something that GCSE examiners are looking for. Let's watch this PhET simulation. It's a free website and the link is in the description. I highly recommend you to go through it and watch it. In this, we have shown how the particle arrangement varies when we change the state. For each state, you see the particles are the same. They are the same color, same size, same shape. Then what is changing? Well, only their arrangement is changing. The way the particles are moving is changing. Let's look into it further. A very common GCSE question which is asked every year is describe each state with respect to the particle model. And we can easily do it using the acronym ARMS. AR is for arrangement, M for movement, and S is for the spaces between the particles or the strength of forces between them. So we are going to practice using this acronym with several examples. Let's try. Looking at the picture, describe the arrangement of the particles in a solid for 3 marks. Since the question is for 3 marks, aim for 3 clear statements. Pause the video if you need to, write your answer on a paper and come back to it later. Alright, let's try doing it using the acronym ARMS. So first we'll try to describe the arrangement of particles in a solid, and we can say particles are packed very closely in an ordered regular lattice structure. For the movement, we must highlight the particles vibrate while remaining fixed in their position. And lastly, for S, we can talk about the strength of the attractive forces. So we can say there are strong attractive forces between the particles which keep them in their fixed positions. Or you can also talk about the spaces between the particles. So you can say the particles are closely packed and thus they have minimum spaces between them. Did you get full score? Okay, let's try one more time. Okay, this time we'll describe how the arrangement and movement of particles differ in a liquid from a gas. So again, we'll use the same acronym ARMS and we'll come up with the 3 clear comparison points to score full 3 marks. For arrangement, we can say how liquid particles are close together, but gas particles are very far apart. For movement, we can say liquid particles can slide past each other, but gas particles move rapidly in random directions. And for the S part, we can talk about how gas particles have negligible forces of attraction between them compared to the liquid particles. So in this way, write 3 crisp, clear points and nobody can steal away your marks from you. Now we are ready to describe what happens during a change of state. So let's look into it closely. So when the solid is heated, the particles gain kinetic energy, they start vibrating fast and they start moving further apart. They keep moving further apart till their forces weaken and the spaces between them increase, like they can slide past each other. They start flowing. This process of changing the solid fixed regular lattice structure to the particle arrangement where they can slide past each other is melting. So particles gain energy reorder themselves, the arrangement and the movement of particles change. That is when solid changes to liquid. A similar thing happens when a liquid is further heated. The kinetic energy of particles will increase, they will start moving faster, and they will start moving further apart. The distance between the particles is increasing. This weakens the forces of attraction between them, and thus the particles move out of their position and escape as gas molecules. The reverse happens during cooling process. When the gas particles are cooled, they start losing energy and condensation to liquid happens. Similarly, when the liquid particles are cooled, they start losing energy and they get frozen into a solid. So during a change of state, particles are not changing. They remain the same. Again, if you notice, the size is same, shape is same, color is same. The particles are same. They don't change. It is only the energy level which changes. This energy is specifically thermal energy. Remember, the change of state is not a chemical change. The particles are same. They do not form any new substance. The substance is same. What changes is their kinetic energy. Now we have reached the last section of this unit, which is gases and absolute temperature. Look closely at the particles of the gases. This random motion is called as Brownian motion, which provides evidence to the kinetic particle model. The kinetic particle model states that particles are always moving. Always moving, that means they always have kinetic energy. They never stop. Understand, even if you are in a solid state, the particles are vibrating. They don't stop. They are never still. Now the measure of average kinetic energy of particles is temperature. We are saying particles are always moving. They always have kinetic energy in them. That means the temperature can never be zero. But 0 degrees Celsius and negative temperatures are very common in these snow-covered areas. We all have come across these negative temperature scales. Then what is happening during this time? A 0 temperature means particles not moving, and a negative temperature means particles are less than not moving. Is that even possible? No, that's not. So scientists have defined a scientific scale called Kelvin, wherein which at 0 Kelvin, the particles have the minimum kinetic energy possible. There's a negligible motion in particles at 0 Kelvin. Let's have a look again at another FET simulation. The link is given in description. So we have this solid water and we are cooling it further. You will see as the temperature is dropping, the motion of the particles is reducing till the temperature reaches negative 273 degrees Celsius. Even if we continue cooling, we cannot drop the temperature any further. This negative 273 degrees Celsius is 0 Kelvin, which we call as the absolute temperature. So Kelvin, scientific unit of measurement of temperature, Kelvin is not given in degrees, it's just given in Kelvin. And remember, 0 Kelvin is negative 273 degrees Celsius. So absolute zero, that is 0 Kelvin, is the lowest possible temperature. You cannot go colder than this. Celsius to Kelvin conversions are favorite GCSE questions. Every year, this question is definitely there in the paper, where they give you temperature in degrees Celsius and ask you to convert into Kelvin. So you simply add the number 273 to the degree Celsius temperature to get the temperature in Kelvin. Let's talk about gas pressure now. As we know, the particles move rapidly in gas. The particles move in all directions, but the particles move in straight line. As they move in straight line, they keep bumping into each other. They keep hitting the walls of the container. And when they collide with the walls of the container, they exert a force on the wall. Now, one tiny particle will exert a tiny force, but imagine billions of particles bumping into the wall of container all at once. That will be a considerable force per unit area of the wall. This force per unit area of the wall is the pressure exerted by gas on the walls of the container. Now, what happens if the temperature increases? When the temperature increases, the particles will gain kinetic energy and they will start moving more rapidly. So, the particle movement will increase. If the particles are moving with greater kinetic energy, they are likely to collide with the walls of the container more often. So, the collisions will increase. When there are more collisions, clearly there is more force on the wall and thus the pressure increases. So, if the temperature increases, the gas pressure increases for a fixed amount of gas at constant volume. Alternatively, if we increase the volume, keeping the temperature constant, when the volume increases, the particles will have more space to move. This will reduce their collisions on the walls. If the number of collisions are less, clearly the force acting on the walls is less and thus the pressure reduces. Important GCSE questions which are asked in almost 60% of the papers. Let's try one of that kind. A student heats a fixed volume of gas and the temperature increases from 20 to 80 degrees. Explain using the particle model what will happen to pressure of the gas when it is heated. It is for 3 marks. Remember, we have to give 3 clear points. And secondly, we have to convert 20 degrees and 80 degrees to Kelvin temperature for 2 marks. So each conversion for 1 mark. Let's start thinking like examiner and do this question together. So for the first part, we have to say 3 points. So when the temperature increases, particles will gain kinetic energy. The particles will start moving faster, should be mentioned. When the particles are moving faster, they will collide more often with the walls. The particle collisions will increase. This is going to increase the force acting on the walls of the container, and thereby the gas pressure increases. Conversion of 20 degrees to Kelvin will require add 273 to 20. So that will give you 293 Kelvin. And for 80, you add 273 to 80. That will give you 353 Kelvin. So in this way, full 5 marks can be earned in this GCSE question. Remember, don't memorize physics. Understand the particles and physics will come naturally to you. I'm Miss Neha. You ask, I explain.